in this problem, we want to prove that the square root of 1 plus 2 square root of 1 plus 3 square root of 1 plus dot dot dot. This is an infinite nested radical. We want to make sure that this value equals to 3. So how do we solve this problem? Well, we can use the reverse way. Start from the right hand side, and then prove that it is the same as the left hand side. Why do we start with the right hand side? Well, 3 is just a number, so we can break down this number. We have square roots here, and we know that 3 is the square root of 9, right? So this is the square root of 1 plus 8, which is the square root of 1 plus 2 times 4. We wrote that as 2 times 4 because we know that we're not going to have 1 plus 2 some square root of something. And we know that 4 can be written as the square root of 16. So keep on breaking this down. So this will become square root of 1 plus 2, some square root of, well, we need a 1 here, so it becomes 1 plus 15. 15 can be written as 3 times 5. We need a 3 because it says 1 plus 2 times square root of something here. So 5 can be written as square root of 25. 1 plus 2 times square root of 1 plus 3 times square root of 25. And it goes on. And we cannot end here. We want to make sure that this is an infinite nested radical. So instead, we can let this, after observing the pattern, we can set a general form. Because we realize that it always ends up in this form and here. And what do these have in common? Well, we know that if from here, since notice that we broke down 9 into 1 plus 2 times 4, and so on. So if we let 9 here equal to a general value n, well, we want to prove that n will equal to, in this case, 1 plus n minus 1 times n minus 2. So then we'll get that. So we have n plus 1 times n minus 1. And in this case, n will be the square root of 9, which is 3. So how do we prove this? Well, to prove this, well, we can take the square. N squared equals to 1 plus n minus 1, n plus 1 times n minus 1, right? So we have n squared minus 1 equal to n plus 1 times n minus 1. This is always true, as this is a difference of squares theorem. And since this is always true, we know that this general form applies to all of this. So this cycle will continue infinitely. So we have, finally, the proof is complete. 1 plus 2 times 1 plus dot 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 equals to 3. So that is how you prove this.